Today we are going to be discussing the trig angle sum and difference identities. We can find the exact values of some trig functions using these special identities, these formulas, and we will learn 3 sets of identities in this unit. So today we're doing the sum and difference identities and I split this up into 2 days. So 2 days on sum and difference identities, and then after that we will do the double angle identities and then the half angle identities. So let's jump in and get these formulas, these identities for the sum and difference of 2 angles for sine, cosine, and tangent. Okay, so the formula for sine of x plus y is sine of x times cosine of y plus cosine of x times sine of y. And of course, since multiplication is commutative, you can switch these. Some students like to keep sine first each time and then cosine second. Of course, you can do that. Just move those around. For sine of the difference of x and y, the formula, the identity is sine x cosine y minus cosine x sine y. So these are identical except for the sign in between them. The identity for cosine of a sum of 2 angles is cosine x cosine y minus sine x sine y. That's the identity for a cosine of a sum of 2 angles. And for the difference, it's the exact same thing, except instead of a minus, we're going to have a plus in between them. So cosine x cosine y plus sine x sine y. The identity for tangent of a sum or difference these identities are a bit more complicated than the ones for sine and cosine. These are a fraction. In the numerator, for this one, we have tangent of x plus tangent of y. In the denominator, we have 1 minus the product tangent x tangent y. The identity for a difference for tangent looks identical to this, except in place of the plus you have a minus, in place of the minus you have a plus. So it's another fraction, tangent x minus tangent y, divided by 1 plus the product tangent x times tangent y. You do not need to memorize these 6 identities. The only identities that we do in this unit that you will need to memorize are these double angle identities. Those I need you to know because they are important. They're super important for calculus. We use those in calculus to take the derivatives, integrals, and to simplify things. All right, using the sum and difference identities. You must make the given angle in a problem a sum or a difference of 2 known unit circle angles. So you want these 2 angles, you want this x and y to be things that you know the sine, cosine, or tangent of because of the way we have it here. So we need for these 2 things to be like something pi over 6 or something pi over 4 or something pi over 3, things like that. Okay? So the key to doing this is to use the sum or difference of 2 numbers which can reduce with the number in the given denominator. You want your reduced angles to be on the unit circle. Okay? Our denominators that we're going to have are all going to be at 12, just to get the idea of what we're doing here. Okay? So you're going to want to have 2 numbers that add or subtract to get your given denominator. Okay, you're given argument, I mean. Okay, let's say you want to find the exact value of cosine of 5 pi over 12. Well, we don't know the cosine of 5 pi over 12. So we're going to change 5 pi over 12 to two numbers that add or subtract to get 5 pi over 12. And then we can use the identities up here. Okay? So we're going to find two numbers, add or subtract to get 5 pi over 12. We want to make sure that those two numbers can reduce with the 12 in the denominator. So we have 5 pi over 12. We want two numbers. I'm thinking to myself, I need two numbers that add to 5 and both reduce with 12. So I might choose 3 and 2 because 3 plus 2 is 5, and 3 and 12 reduce, and 2 and 12 reduce. I would not use 1 and 4, even though 1 and 4 also add to 5. The 4 would reduce with the 12, but the 1 would not reduce with 12. So I would not use the 1 and 4. So this reduces 3 pi over 12 reduces to pi over 4. 2 pi over 12 reduces to pi over 6. And so we can substitute pi over 4 plus pi over 6 in place of the 5 pi over 12. So this would be cosine of pi over 4 plus pi over 6. And then we would use our identity for the sum of cosine with the sum of angles in there. I would use that identity to simplify that, to get that value. Okay? Let's look at another example here. In this example, we want to use a sum or difference identity to find the exact value of sine of pi over 12. So to begin with, I'm thinking to myself, I need two numbers that add or subtract to get pi over 12. So I know the denominator is going to be 12, and I know I'm going to need a pi in here. And I can put a plus or a minus. Since this numerator is just a 1, I'm guessing that I'm going to need a minus here. Okay? So I need two numbers that subtract to get 1. Well, 3 and 2, 4 and 3, things like that. I might use 3 and 2 because they're small, and both of those reduce with the 12. So they reduce to pi over 4 minus pi over 6. I could also have used 4 minus 3. 4 over 12 reduces to pi over 3, and 3 pi over 12 reduces to pi over 4, and those we know. So either one of these will get you the exact same answer. Okay? I'm going to use this one just because I did it first. So now I'm going to write sine of pi over 12 is sine of pi over 4 minus pi over 6. And now I'm using the identity for the difference for sine. The difference for sine, which remember was sine x cosine y minus cosine x sine y. So sine pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. And now we're going to use our unit circle values to fill those in. So let's see, what is sine of pi over 4? Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root 3 over 2. Cosine pi over 4 is square root 2 over 2. Sine of pi over 6 is 1/2. And now we're going to get to one of these multiple choice answers. The square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. We have common denominators, so we can write this all over one denominator, and we'll have square root of 6 minus square root of 2. And as a reminder, you cannot change, there's no way to reduce or to simplify square root of 6 minus square root of 2. Nothing you can do with that. Okay? So our answer is going to be, we have a positive square root of 6 and a negative square root of 2, so it's looking like B. So this answer would be B. Let's do another one. We want to find the exact value of tangent of 13 pi over 12. So step 1 is to find the two angles that add or subtract to 13 pi over 12. So I set this up like that. Okay. Since 13 is a fairly large number, I'm guessing I'm going to have a plus here. So I need to find two numbers that add to 13 and reduce with the 12. Add to 13 and reduce with 12. So I'm thinking maybe 9 and 4. 9 plus 4 is 13. And 9 reduces with 12. They have a common 3. 4 reduces with 12. They have a common 4. So this will be 3 pi over 4 plus pi over 3. A word of a suggestion. Since we have tangent, it's more convenient to have a pi over 3 than it is a pi over 6. If you have a pi over 6, you're going to have a fraction within this fraction here. And you're going to have, that will make a complex fraction. It will just add one more step to your problem. It's not a big deal. But when I can, I would rather have a pi over 3 than a pi over 6 when I'm dealing with tangent. So now we have tangent of 13 pi over 12 is tangent of 3 pi over 4 plus pi over 3. And now I'm using my identity. This is equal to, I think I'm going to come down below. With tangent, I know I have some simplifying to do at the end. So the identity is tangent of 3 pi over 4 plus, if there's a plus here, I know there's a plus right here for tangent, plus tangent of pi over 3 divided by 1 minus the product of those two. Tangent of 3 pi over 4, tangent of pi over 3. Okay, so I'm going to need something for tangent of pi over 4 and tangent of pi over 3. And then on the bottom I'm going to have a 1 minus, and then I'll have tangent of 3 pi over 4, tangent of pi over 3. I like to set those up with the parentheses, make sure I got everything filled in. Alright, tangent of 3 pi over 4. Well, tangent of pi over 4 is 1, but 3 pi over 4 puts it in the second quadrant where tangent is negative, so this is a negative 1. Tangent of pi over 3 is square root of 3. We have to know our unit circle values really well. And then tangent of 3 pi over 4 is still that negative 1. Tangent of pi over 3 is still square root of 3. Okay, so we have negative 1 plus square root 3 divided by 1 plus square root 3. And that's a fine answer to me, but it's not one of our choices. So what did they do to get one of the choices there? Well, they rationalized that denominator. So we're going to come in and rationalize the denominator by multiplying by the conjugate of that denominator, 1 minus square root 3. But of course we can't just multiply the bottom by 1 minus square root 3, we also have to multiply the top by 1 minus square root 3. So we multiply top and bottom by the conjugate of the denominator. And now I'm going to FOIL it out. Negative 1 times 1 is negative 1. Negative 1 times negative square root of 3 is positive square root 3. Square root 3 times 1 is another positive square root 3. And square root of 3 times negative square root of 3 is negative 3. All divided by 1 times 1. 1 times a negative square root 3, positive square root of 3 times 1. Since we multiplied by a conjugate, I knew that would happen. I knew that those two would cancel each other out. And then positive square root of 3 times negative square root of 3 is minus 3. In the numerator, we have negative 4. We have 2 square root of 3's, so 2 square root 3, divided by negative 2, and then the middle term, this will always cancel out because of the conjugates. Okay, so we have this. We're almost to one of our choices. I see that I have a common 2 in the numerator, and I have this 2 in the denominator, so I'm going to reduce that. I'm going to put both of the numbers, here's one way to think about it. I put both of these numbers all over the 2. Another way to think of that is I'm factoring out. If you factor out a 2 or even a negative 2, this will work the same way. So negative 4 over negative 2 plus 2 square root of 3 over negative 2 is 2 minus square root 3. So that is the correct answer, D. Okay. Number 3. This time we're finding the exact value of cosine of 11 pi over 12. Cosine of 11 pi over 12. So I need two numbers that add or subtract to get 11 pi over 12. 11 is another pretty big number, so I'm going to assume we're going to have a plus here. Although I'm looking at that and I see one that we could have a minus with, but plus will work here, I think, maybe. Okay, two numbers that add to get 11. How about a 2 and a 9? 2 and 9 will work. 2 plus 9. Okay? I think that'll work. So 2 plus 9 is 11, and both of those will reduce with 12. So 2 pi over 12 is pi over 6. 9 pi over 12 is 3 pi over 4. So I will have cosine of pi over 6 plus 3 pi over 4. And now again, I'm using my cosine of a sum identity that was right here. So it's cosine x cosine y minus sine x sine y. So cosine pi over 6 cosine 3 pi over 4 minus sine pi over 6 sine 3 pi over 4. Okay? Cosine of, oh well, let me put my little parentheses. Cosine of pi over 6 is square root 3 over 2. Cosine of 3 pi over 4, it's in the second quadrant. Cosine is negative in the second quadrant. It's a pi over 4 reference angle, so square root of 2 over 2. Sine of pi over 6 is 1/2. Sine of 3 pi over 4, second quadrant, sine is positive, square root 2 over 2. So we'll have square root of 6 over 4, and that'll be a negative, minus square root 2 over 4. So this is negative square root of 6 minus square root of 2 all over 4. So both negative, that puts us at answer choice D. Okay, one more of these. 23 pi over 12. It's another tangent. So if possible, I'd like to make these pi over 3's, if possible. Or well, not pi over 3s. I would like to avoid a pi over 6 if possible. I might want to, for the sake of showing you how to do it, I might want to put a pi over 6 in there. So we'll see. If it happens, it happens. Okay, so let's see. What two numbers? 23 is fairly large. I'm thinking we're going to have a sum here. We want two numbers that add to get 23. Add to get 23. I'm thinking maybe like a 15 and an 8. 15 and 8 add to get 3. And there's a common 3 in those, and there's a common 4 in those. So I think that'll work. Let's see what we get when we reduce. 15 over 12 has a common 3, so that would be 5 pi over 4. There's a common 4 in these, so that's going to be 2 pi over 3. Okay? So that brings us to tangent of 5 pi over 4 plus 2 pi over 3. Using our identity for tangent of a sum, this will be tangent of 5 pi over 4 plus tangent 2 pi over 3, all divided by 1 minus the product, tangent 5 pi over 4, tangent 2 pi over 3. Okay? So I need some values. Now we go and we get our unit circle values. So tangent of 5 pi over 4. Well, it's tangent of a pi over 4, so I know it's going to be a 1. 5 pi over 4 is in the third quadrant where tangent is positive. So this is just a positive 1. Tangent of 2 pi over 3 is going to be a square root of 3, but it's going to be negative because it's over here in quadrant 2. So negative square root 3. So tangent of pi over 4 was 1. Tangent of 2 pi over 3 was negative square root 3. So we have 1 minus square root 3 divided by 1 plus square root 3. Okay? All right, time to rationalize. So again, I'm going to multiply the denominator by its conjugate. But I cannot just multiply by something in the denominator to keep it equal. I need to multiply the top by that same thing. So FOIL this out carefully. 1 times 1 is 1. 1 times negative square root 3. Negative square root 3 times 1. Negative square root 3 times negative square root 3 is positive 3. Divided by 1 times 1 is 1. I know this middle term is going to zero out, but I might write it down just for the sake of your notes. This will be a negative square root 3 and a positive square root 3. Those should always cancel each other out if you have the correct conjugate. And then minus 3. So up on top we have a 4 minus 2 square root 3 divided by negative 2. So that is 4 over negative 2 minus 2 square root 3 over negative 2, which is negative 2 plus square root 3. Negative 2 plus square root 3. Answer choice A. So those are the examples for today's worksheet. Tomorrow we're going to be using the same identities, but with different types of problems.